Hi, greetings, and welcome to the Geographic Information System course. We'll examine how to visualize GIS products in this session. Maps of various kinds and GIS spatial data models will be covered. We hope you can comprehend maps' different types and specifics by the end of this instructional video. In GIS, a geographic, location-based, data object is referred to as an information product. Some traits define an information product. It is vital first to understand each character to get the correct product based on user needs. Several maps are frequently used when we talk about GIS, including static maps, web scenes, time maps, animations, charts, and story maps. According to the usage as a kind of map in the form of a traditional map, typically printed. Map products come in many shapes, including rainfall maps, ISOYT, neighborhood maps, and geological maps of a region. The map might be static when utilized in a printed edition. The most recent data is published after the map has been incrementally updated. A web map is similar to a digital map accessible through an internet-connected computer or mobile device. You may already be familiar with web map products such as Google Maps, Waze, OpenStreetMap, and OSM Map. The data used as the base map is the result of digitization plus the existence of supporting entities as map details. A web scene is a cinematic map or interactive animation to explain the map's details. Only electronic devices with access to the web can access this sort of map. Animation map is similar to web scene but is specific to explaining certain topics on a small scale. It is necessary to provide a thorough explanation of the data in stages. A time map uses a timeline to illustrate a specific topic's development. Map illustrations can be 2D images or infographics. Time map and chart map are both types of maps. However, chart map is more common in explaining the statistical results of an area in a chart format. Numerous map types can support a time map. We will move on to the types of GIS spatial data at the core of today's lesson content: vector and raster data. GIS vector data represents the Earth's shape in a set of broad lines as an area bounded by a polyline, where these lines start and end at the same point. In general, layers organize vector data into distinct categories. Generally speaking, vector data can be used for a wide range of tasks, including applications that demand accurate data, when specific map properties are required for analysis, and when descriptive data needs to be preserved. Vector data represents the Earth's shape in a collection of lines, areas, points, and nodes. The vector data model is the most widely used, and this model is based on points with coordinate values, x, y, to construct spatial objects. Three components make up the constructed object: points, lines, and polygons. The easiest way to represent an object graphically is with a point. The location of healthcare facilities, among other things, can be shown as a symbol on a map or a computer screen, even if points have no dimensions. A line is a linear form that connects two or more points and represents objects in one dimension. An example of its application is to show roads, rivers, area boundaries, etc. Areas, or polygons, are representations of objects in two dimensions. Examples are lakes, parcels of land, and others. Topological and non-topological vector data are the two different types of vector data. In GIS geographical analysis, topological data is a typical sort of data. A vector data model called topology depicts the connections between spatial things. While digitizing and analyzing complex spatial data, this data helps identify errors. Meanwhile, non-topological data is a data model with properties that are faster in displaying and, most importantly, can be used directly in different GIS software. Non-topology displays or processes simple spatial data, and the file size is not too big. It is expected of you that you are aware of the distinctions between these two formats. For instance, in the Esri product format, a non-topological format refers to a shapefile, but a topological format relates to coverage. Another topic covered will be the categorization of the distribution of GIS spatial data models. In this section, we'll examine raster data in more detail. Remote sensing systems produce this data. Pixels, or grid cell structures, are used to depict geographic objects. Resolution refers to the size of the representation of the Earth's surface by each picture pixel. The raster data model summarizes spatial information about the Earth's surface. The depiction of continuously changing boundaries, such as soil type, soil moisture, vegetation, and temperature, is common in raster data. Aerial shots, satellite images, scanned paper maps, and other digital data that call for precise images are all represented as raster data. Another benefit of using raster data is that it is cost-effective. Users may experience a lack of funds due to high other expenses such as field survey fees. So, they can take advantage of raster data in satellite images or aerial photographs. There are yet other applications for raster data, mainly when it is not necessary to analyze each feature individually for the map. Raster data can also be employed when a base map is required for the user's map view. There are four main categories in the utilization of raster data types or format, namely raster as base maps, surface maps, thematic maps, and attributes and objects. additional item layers or vectors as typically a raster-based map. The following graphic displays a flood risk map with a background image created using recent quick bird imaging data, illustrative of this. Raster is also suitable for displaying Earth's surface data because it is pretty effective in storing the elevation value of the Earth's surface. For example, you can look at the following image, which is a raster data model representing the elevation of a rural area. It is possible to create raster data that displays themed maps using the results of further data analysis. This study typically employs a more detailed application. Raster classification is a method for classifying satellite images based on land use or cover. The following image shows how Landsat image data is utilized for land cover classification. The description of a property of an object, such as a digital photo, scanned document, or scanned image that is connected to the object or a location, can also be done using raster data. An example of a parcel ownership document that can be presented as a parcel object attribute is shown in the image below. Between the two data formats above, there is a fundamental difference between vector data and raster data. This difference lies in the method geographic objects are stored and displayed. Each data format has its advantages and disadvantages. The choice of data format usually depends on the intended use, data availability, volume of data generated, desired accuracy, and ease of analysis. Insert vector and raster. Meanwhile, raster data is known to be easy and efficient in the overlapping process, compatible with satellite image data, has a more straightforward data structure, is efficient for representing high-resolution spatial data, and is efficient in manipulating digital photo data. In contrast, raster data is known to be challenging to display topology data, and the resulting data size is relatively large. We can see that both vector data and raster data have complementary advantages and disadvantages. These two GIS data models were sourced from various places. Primary information was collected from vector data from GPS and topological surveying. Meanwhile, secondary data was obtained from topographic maps and toponym databases. Preliminary data for raster data is obtained from digital data from aerial photos and satellite images. Secondary data for raster data is obtained from digital elevation model, photo, surface modeling, and terrain modeling data. Long before this digital map model was available, all the information contained in GIS was obtained from conventional maps or paper maps whose contents were changed for adjustments and digitized. These advanced acquisition techniques allow the creation of maps that can be directly integrated into a GIS. This time, the video discussion will end after providing an overview of the various map models and data types. In the following video, we will delve further into GIS features, elements, and structures in connection to the earlier covered map modes. I'll see you later.